Hello friends, welcome you all. In last lecture, we are then bulking of sand, and the lastly measurement of the bulking of sand. Now, in this lecture, we are going to discuss the properties of coarse aggregate. So, what are those properties? Let us see. First is size, second one is shape, third one is surface texture, fourth one is specific gravity, fifth one is bulk density, sixth one is water absorption, seventh one is fineness modulus, eighth strength, and lastly alkali aggregate reaction. So these are the properties of coarse aggregate. So what effect of this property of coarse aggregate? So let us see. First, size. If coarse aggregate is of larger size used in it gives less workability and concrete become porous in nature. Okay, so it means we should be select such size of coarse aggregate so our concrete will not be a less workable, it should give a good workability. So this size factor give the various effect while mixing in the concrete. So the coarse aggregate should have a medium size, so concrete not become a harsh or it is a good workable one. Next is the shape. If the shape of concrete, if the shape of coarse aggregate particles is flaky or elongated, will result in a difficulty in mixing. Okay, even rounded coarse aggregate will give a weak interlocking of particles, but wide ratio is less. Angular shaped coarse aggregates gives the required bonding and strength. So it means for mixing the concrete, we are using the coarse aggregate such that it should not be flaky or elongated one, because it gives the difficulty in mixing, and it should not be a rounded one also, because it gives a weak interlocking and less void ratio. So shape of the angular such that it is the angular one. Okay, angular shape we are preferred for the concreting, so it gives the good bonding and as well as the strength. Next is the surface texture. Smooth surface texture of coarse aggregate mixed with sand will result in the lower cavity in the form of segregation, and the rough texture aggregate will give the strength to the concrete. Means we should use such type of coarse aggregate which having the rough surface texture. Okay, so if smooth surface texture is there, it gives the lower workability, and rough surface texture gives the good strength to the concrete. So next one is the water absorption. If coarse aggregate has more water absorption capacity, then concrete will become harsh and indicating reduced workability and honeycomb finishing. Okay, so coarse aggregate should be selected such a way that it does not having the water absorption property, means it does not absorb the water from the concrete. Okay, if it absorbs the water from concrete, the concrete become harsh one, and which results in a honeycombing of the that concrete. Okay, and it also reduces the workability of that concrete. So next one is the specific gravity. The more specific gravity of coarse aggregate will increase the dead load of concrete structure, and the lesser specific gravity gives the lightweight concreting. So the specific gravity of coarse aggregate should be a less one. Okay, so the it gives the lightweight concreting. Next is the bulk density. If the bulk density of coarse aggregate is more, then lesser voids in the concrete gives dense and compacted mass, but less bulk density of coarse aggregate requires more cement slurry and may result in porous concrete and uneconomical concreting. So the bulk density means the we have to reduce the voids from the concrete. Okay, if more voids in the concrete, we require the more cement placed or more cement slurry to acquire this total mass. So the to avoid these voids or more voids, we have to dense the coarse aggregate such that it gives the dense concrete and a compacted mass. Okay, so it is the economical one. If it is not so, then the concrete become uneconomical and porous one. Okay, next is the fineness modulus. If fineness modulus of coarse aggregate is not in between 2.9 to 3.2, then such aggregate will not be well graded. Okay, hence it will not satisfy strength requirement. So the fineness modulus should be in between the 2.9 to 3.2 to satisfy the strength requirement of concrete. Then impact or crushing strength. So the impact or crushing strength of coarse aggregate should be less than 45%. Okay. So otherwise load carrying capacity of concrete will be reduced. Okay. Means coarse aggregate should be sustained for more impact or crushing. Okay. And this aggregate should not be crushed or impact strength such that it should not be less than 45%. Okay, means the load carrying capacity of concrete will not be reduced. Next is the alkali aggregate reaction. This is the undesirable reaction takes place due to the chemical reactive aggregates which give rise to various cracks on concrete surface. Okay, so aggregate should be selected such a way that it should not be chemically inert. Okay, chemically reactive one. So if it is so, it will be react to the alkali. Okay, and which gives the various cracks on the concrete surface. So we have to take the care of that the aggregate should not be a reactive one. Next is the testing of coarse aggregate. So what are the tests conducted on the coarse aggregate? Let us see. First, water absorption. Second, fineness modulus. Third, impact value test. Fourth, crushing value test. Fifth, abrasion value test. And lastly, flakiness index and elongation index test. So let us see first water absorption of coarse aggregate. We know the coarse aggregate should absorb the less water. Okay, if it absorb the more water from the concrete, then concrete become harsh one. Okay, so it will reduce the workability also, okay, of concrete. So let us see how we can find out the water absorption of coarse aggregate. So the procedure, first point is take the sample of aggregate not less than 2000 gram, then wash this sample thoroughly and remove the dust particle and dust from this sample. Okay, next drain out the sample and immerse it in the water at a temperature of 30 degree with a cover of at least 5 centimeter of water above the top of the container, and keep this sample immersed for the period of 24 hours afterwards. After this 24 hours, remove the water from container and allow drain for few minutes and allow to concrete to surface dry. Then take weight of the surface dry and saturated aggregate, that is W1 in gram. Next, then place this aggregate in tray at a temp and means place this aggregate in an oven at a temperature of 100 degrees Celsius to 110 degrees Celsius temperature of this oven. Okay, so the maintain under the same temperature for 24 hours. Okay, after then remove this sample from the oven, allow it to cool and air and record its weight, that is W2 in grams. And finally find out the water absorption of coarse aggregate is equal to W1 minus W2 upon W2 multiplied by 100. We get the water absorption of coarse aggregate in percentage. Okay, where W1 is what? W1 is the surface dry weight of that sample, and W2 is what? It is the oven dry sample. Okay, so W1 minus W2 upon W2 multiplied by 100 gives the water absorption of coarse aggregate in percentage. So hope you will understand this session. Thank you.